Here we have a stoichiometry problem that is based on precipitation reaction. As you can see here, 10 milliliters of aqueous solution of sodium chloride is reacted completely by mixing with excess of lead nitrate. So let's underline the reactant. Sodium chloride is reacting with lead nitrate. And 2.10 grams of precipitate was produced. So this is your product, and we know how much product is produced. You're asked to calculate the molarity of the sodium chloride. This is a stoichiometry problem since you're relating amounts of products to reactants. In any stoichiometry problem, you need a balanced equation. So our first step would be to write out our balanced equation. So let's write it out. I'm going to write it here on the top. So your reactants are sodium chloride and lead nitrate solutions. So sodium chloride solution, it's a solution, so we put AQ as the state, plus lead nitrate, that's the formula for lead nitrate, and it's an aqueous solution that we are mixing. Those two are going to react to produce products. And this is a reaction between aqueous solutions. And so we can use double displacement reaction. That means the cation here goes with this anion. Let me underline those. This cation put together with that anion. And this anion, you put it together with this cation. Okay? And write the correct formulas. So we need, one of the products here is going to be sodium nitrate. Think about what its formula is going to be. Sodium ion is Na+. Nitrate is NO3 negative. So one positive, one negative. So to make a neutral compound, we just need one of each. So sodium nitrate's formula will be NaNO3. Okay. Now what will be its state? Is it our precipitate, or is it a soluble compound? We are going to look at the solubility chart, and you don't even have to look at it because we said nitrates. I asked you to memorize that nitrates are always soluble. So this is a soluble compound. So the state here is going to be aqueous. Sodium nitrate is in dissolved form. And the other product is going to be lead chloride. Lead chloride. And the lead ion's formula is Pb2+. Okay, and how do I know it's 2+? Because I have two nitrates there. The charge on each, the lead should have been 2+. Okay, because of how the positive and negative charges should balance. Since there are two nitrates, you have two negative charges. That means the lead should have two positive. Now chloride ion, we know from the periodic table that it's in the 7th group, so chloride is always Cl negative. So what is the charge, what is the formula of lead chloride? For each lead, we need two chlorides, because if there are two positives, we need two negatives, okay? So lead chloride's formula will be PbCl2. And if you look at the solubility chart, chlorides are soluble, but when they're combined with lead, it's an exception. So lead chloride is an insoluble compound. So this is our precipitate. So you put the state as solid, and this is our precipitate. So when the problem is saying 2.1 grams of precipitate was produced, 2.1 grams of lead chloride was produced. So let's write that down. So we have one information here. 2.10 grams of lead to chloride is produced. Okay? All right. We have a balanced equation. Great. And we have amount of one substance. Great. And remember, the heart of stoichiometry is moles. Okay? If you know moles of one substance, then you can change it to moles of another substance. That's the heart of stoichiometry. So whose moles can we know? Well, you have grams here. If you know the molar mass of lead chloride, you can change this to moles. Okay, so that's our first step. We are going to look for a way to calculate moles of one substance. So we can calculate the moles of lead chloride. So I'm going to convert mass of lead chloride to moles of lead chloride using the molar mass of lead chloride. Turns out molar mass of lead chloride, I calculated it ahead from the periodic table, and turns out it is 278.10 grams per mole. That's the molar mass of lead chloride. That means 1 mole of lead chloride weighs 278.10 grams. And I wrote it so that I can cancel out grams of lead chloride and go to moles. Once we have moles, where do we go next? As I said, once you know moles of one substance, you can find the moles of the other substance. So which substance are we looking for? We are looking for the molarity of sodium chloride. And we know that we have the volume, okay? So molarity is moles over volume. So since we need the moles of sodium chloride, that's where we're gonna go. We're gonna go from moles of lead chloride to moles of sodium chloride. And the connection between those two is from the balanced chemical reaction, okay? Now I wrote a reaction, but I didn't balance it. So let's go ahead and balance it. You have 2 nitrates there, so I need a 2 here. Okay, that would make 2 sodiums on the right, so I need 2 sodiums. So let's have a coefficient of 2 there. Look at it, is it balanced? 2 sodiums, 2 sodiums, 2 nitrates, 2 nitrates, 1 lead, 2 chlorides, 2 chlorides. This is balanced now. Now we can use the molar ratio between lead chloride and sodium chloride. That's 1 to 2. For every 1 lead chloride, there should have been 2 moles of sodium chloride in the solution. Okay, so if you produced that much precipitate, you can convert that to moles by dividing by molar mass, and you can convert that to how many moles of sodium chloride should have been there because it produced that much precipitate. We are estimating how many moles of sodium chloride were in that solution. Okay, so once we know the moles, let's calculate the moles, and this, multiply those two, divide by this, and you should get 0.01510 moles of sodium chloride. And once you have moles of sodium chloride, these moles, okay, should have been in the 10 milliliter. Okay, these should have been all the moles in the 10 milliliter. As you can see, you're reacting the sodium chloride completely. That means you have reacted all of these moles. And all these moles are present in the 10 milliliter that you used. Okay, in other words, let me put the word use so that may make it more clear to you. 2 grams of lead chloride produced means 0.0150 moles of sodium chloride was used. Okay, so that's the moles used. The volume of NaCl used is 10 milliliter. Okay, and all these moles are in that 10 milliliter because this is a limiting reagent. All of these were used to produce the precipitate. Okay, so we can calculate the molarity. So the molarity of sodium chloride is, molarity is always moles over liters, so we need moles of sodium chloride divided by the volume in which those moles were present. Okay, and volume should be in liters. So we can substitute now. Moles is 0.01501 and volume is 10 milliliters would be 10 milliliters and liters. They differ by a factor of 1,000. Okay, that means if you want to go to liters, the number before it should be smaller. Okay, if you're going to a bigger unit, the number gets smaller by 1,000 times. So we can just move this decimal 3 times to the left. Okay, that's another way to figure it out. So that would be 0.010 liters. Okay, 10 milliliter is 0.010 liters. and you divide those two, that's going to give you the molarity. And this is going to be 1.51 rounded off to 3 sig figs. Okay, 3 sig figs here, 3 sig figs there. So your answer should have 3 sig figs. And the unit is moles per liter. Moles per liter can also be abbreviated as capital M, and we read this as 1.51 molar. Okay, molar. This M stands for molar or molarity. Okay, that's it. What we did is just stoichiometry. Using grams, we went to moles, then moles of A to moles of B using the stoichiometric ratio. Once we have the moles, we divided by the volume in liters and got the molarity. That's it. And what we just did is called solution stoichiometry because it's stoichiometry involving solutions.